الرحمن الرحيم. In the last part, we spoke about the organizing data. And we say organizing data or constructing something called a frequency distribution. It's just kind of organization of the raw data in a table form. And we said that we have two types of the frequency distribution. One of them is called the categorical distribution, which was discussed last time. And the second one is called the grouped frequency distribution. And this will be discussed in this part. For the group frequency distribution, let's take this example to explain the detail of this frequency distribution, grouped frequency distribution. From the title grouped, means we are going to put the data in groups or some intervals. Usually this is work for the quantitative variables. Remember that we mentioned before that we have two types of the variable, qualitative and quantitative. Quantitative means numerical value. It's a variable that attain or assume numerical values. This value, sometimes the difference between the largest and the smallest value is very large, so we need to construct all of the data in groups. So let's take this example to explain the detail for this type of distribution. The following are the scores of 30 students in statistics. We need to construct a frequency distribution with 7 classes. This will be the number of the classes or the number of groups. So I need to construct a frequency distribution. To construct the frequency distribution for the grouped data or group of frequency distribution, we need a couple of things. First one, we need to find the range of the data. Range of the data is equal to the highest value minus the lowest. Because it is H for the highest minus L for the lowest. The highest value we have in this data, we can go through this one by one to see what is the highest one. It is 94. Or not 94, there is another one, bigger or larger. It's 95. So the highest value is equal to 95 minus the lowest. Lowest one, let's just look for the lowest one. It is 45. So the lowest value in this data is 45, which is equal to 50. So the range of this data is equal to 50. Take the highest one and lowest one and find the difference between them. The difference between the highest and the lowest is called the range of the data. Why do we need the range? The range of the data is used to find the class width. Class width, the value is equal to R divided by class number. That will be 50 divided by 7. The classes or the class numbers is given 7 classes. We need to construct the frequency distribution using 7 classes. So we divide 50 by 7. That will be 7 point something. It's 50 divided by 7 is equal to 7.14. Since we have decimal and all the data are integer, this must be rounded up. So we are going to use class width. Let me say, we are going to round it up to say the value or the class width is equal to 8. We are going to use 8. So in each time to find the class width, we have to round it up. If the class width is having to be integer, in that case, we need to add one more class. We see this now. Now the class width is equal to 8. Now I have the class width, I have the range. We can start constructing the frequency distribution. For the frequency distribution now, we're going to start with something called the class limits. Class limits or limits. Start with the lowest one. The lowest one was 45. The lowest value is 45. Then add the value, the class width. Each time add the class width, which is 8. 45. Next one will be 53. Next one is 61. Next one will be 69. Then we have 77. Then we have 85. And last one will be 93. Let's count how many we have. 1, 2, 3, 4, 5, 6, 7. So these are 7 classes. Now these are the lower limits of the class. When we say group data, it means I have lower limit and upper limit. For each class we have lower limit and upper limit. Now these are the lower limits. Write it down. These are lower limits. Now I need to write the upper limit. For the upper limit, I started with 45. Let's go to the next class, which is start with 53, and take 1. That will be minus 1. So 53 minus 1 will be 52. So this is the upper limit for the first class, it is 52. Take the lower limit for the second limit and subtract 1. Take 1 from that one. I will have 52. Now add the value for this one. So next one, we add the value for 52. It will be 60. Next one will be 68. Next one will be 77. Next one will be 84. Next one will be 92. Next one will be 100. So these are the class limits. We have lower limit and we have upper limit. This one or this slide will be the upper limits. Upper limit. Now if we try to have the class width, start with 45 to 52. Next one, 53 to 60. Next one will be 69 to 77. Now, notice one thing here. This is the first class. This is the second one, third one. This area or this interval, these are just gaps. And we don't want to see these gaps. We have to make all the classes continuous, starting with the upper or lower limit to the upper limit. Now the next class should start with the upper limit of the previous one. Now these gaps must be closed. And to close the gaps, we are going to use something called the class boundaries, not the limits. Class boundaries. Now the class boundaries, to find this one, we are going to subtract 0.5 from the lower limit and add 0.5 to the upper limit. Subtract 0.5, since all the limits are integer, we are going to deduct 0.5 from the lower limit and add plus 0.5 to the upper limit. This is just to close the gaps between the classes. So the class boundaries will be take 0.5, will be 45 or 44.5 to 52.5. We take 0.5 from the lower limit, add it to the upper limit. Now the next one will be 52.5 up to 60.5. Next one will be 60.5 to 68.5. You can see upper limit is the same of the lower limit for the next class. Upper limit for the second one is the lower limit for the third one. So in this way, we will have continuous classes. Next one, it will be 68.5 to 77.5. Next one is 77.5 up to 84.5. Next one will be 84.5 up to 92.5, and the last one is 92.5 to 100.5. Why do we need continuous classes? Because we are going to use this in the next lecture to graph or to represent the data using some graphs. One of them is the histogram, which is continuous bars. And that's why we need continuous classes. And we are going to use the boundaries, not the limits, for the graphs. Now for the next one, we are done from the class limit boundaries. Now I need to tally these data. And then the last one, we will write the frequency. Now for the tallies, let's see, let's go through this one by one. 45, it is in the first class between 44.5 up to 52. So this is one bar for that one. 55 is in the second one. 85 is between 84.5 to 92. Next one, 74, it will be between 68 to 77. 70, also 68 to 77. 61, be 60.5 to 68. 80, that will be this class. 90, the sixth one. 62, it will be in the third class. 84, it will be in the fifth one. This is done. 84.5. 66, this is in the third one. 77 in the fourth one. 81 will be in the fifth one. 95 In the last one, 77, again, it is in the fourth one, 75. Now for this I will just form one set because I have 5 now, 5 bars. 75 again, 1 bar there, 78, the fifth one, 67 in the third one, 88 in the sixth one, 54 in the second one, 59, third one, second one, 79 will be in the fifth one, so this is one set, 84, it is also in the sixth one, 92, sixth one, 60, it is in the second one, and 94, last one, 85, this is one set of the sixth class, 76, another one, and 61 is in the third one, so this 4. So you can see the frequencies now will be 1 bar I have for the first class, 4 for the second one, 5 for the third one, 7 for the fourth one, 6 for the fifth one, and 5, and last one is 2. So these are the frequencies for the classes. You can see we constructed or formed groups to contain this data. Usually we are using a group data if we have large range. This should be a remark. If the range is very large or large enough, we use group data because we are not going to construct classes more than, let's say, usually not more than 12 or 15. But this is 50. If I want to list all the data, I should have 50 rows, which is not good for the organizing the data. So if the range is large, we are using grouped frequency distribution. Now, and this is the frequency distribution. We need to check and to find the total for the frequencies. This is 5, 10, 17, 23, and 7 to 30. And here we go back. Example say that we have 30 students. So we have 30 at the end, but the total for the frequency is equal to 30. Now I have to mention one remark for the classmates. Sometimes the frequency distribution is already given and we need to find the class width. Now to find the class width. If the frequency distribution is already given and we need to find the class width. The class width is equal to, it is the difference between two lower limits or the difference between two upper limits. L for H, not the lowest, I mean the lower limit and upper limit. This is equal to U1, or should be 2 minus 1, sorry. 2 minus. So to find the class width, I need to use 2 consecutive lower limits or 2 consecutive upper limits. Any 2 lower limits or any 2 upper limits. And it is not equal to the difference between the upper minus lower limits. If we are using the class limits, it is not equal to the upper limit minus the lower limit for the same class. As you can see, the difference between 52 minus 45 is 7, which is not correct. If I use the first one, upper minus lower, 52 minus 45 is equal to 7, which is not correct. So I have to use 2 lower limits or 2 upper limits if we are using the class limits. But if we are using the class boundaries, it's okay to use the upper boundary minus the lower boundary. We have to be careful about the class width. It is the difference between 2 lower limits or the difference between 2 upper limits if we are using the class limits. If we are using the class boundaries, it's okay. We can use the upper boundary minus the lower boundary. So this is not equal to the upper limit minus lower limit. We have to be careful about the class width.